Hi, welcome to this course on technical terms related to daylighting. In this, we'll be talking about three terms. So, one will be talking about quantitative terms related to daylighting. Second would be qualitative, and we would be also covering the performance metrics related to daylighting. Let's start with the quantitative terms. The first term that I would like to discuss is on luminous flux. Luminous flux is basically the amount of light flowing through a space. It can be compared to a shower head to understand this concept. The unit of measurement of luminous flux is lumens, and it is same in IP and SI units. Just to compare it, it's basically you can compare it with hot water flowing out of a shower head. Lumen flux is the lumens that are coming or flowing out of a lamp. So now let's just take this small example. So we have a red lamp and a green lamp. So the amount of light output or lumens out of the red lamp is around 700 lumens, and of green is 1000 lumens. So from lighting perspective, it is clear that you would like to go with a fixture which has got higher lumen outputs because you will get more of light output from that fixture. This brings to us an important concept of energy use. So let's try to correlate the lumen output with an energy use. So that brings us to a term called efficacy. Efficacy is a simple term, or is called an energy efficiency. It's basically the light output divided by the energy input. So light output in terms of lumen and energy input in terms of watt. Basically, what it means is for every watt of electricity used, what is the lumen output from that lamp? Yeah. So now let's just revisit that same example. So with the red and the green lamps giving 700 to 1000 lumens. Now let's add the wattage to that. So my red lighting fixture is consuming around 10 watts, and the green is consuming 25 watts. So now if we translate this into lumens efficacy value, so we get 70 lumen per watt for red lamp and 40 lumen per watt for green lamp. So it's now clear, and it changes the perspective that now from energy use perspective, I would definitely like to go with red lamp because it is giving me more lumens, more light to output compared to the input of energy electricity into the fixture. Now, moving to the next term is illuminance. So, luminous flux we have understand. Now, let's get into illuminance. Illuminance is the amount of light falling on a surface, and it's basically the and the surface is generally measured in square foot and or square meter. So, you can translate this into it's basically lumens falling per unit area of a surface. In terms of measurement, it is measured as foot candle in IP units and as lux in SI unit. It's different just because there is a square meter and square foot difference. So 1 foot candle is approximately 10 lux. That's the correlation between square foot and square meter. Illuminance can be measured by a light meter. All you have to do is take this light meter and hold it near to the surface, and it will give you the amount of light that is falling on this sensor and or on that surface. Now let's come down to luminance. So whatever light is falling on a surface is kind of reflected back. So that is called luminance. So light reflected from a surface is called luminance as per a definition. It is measured as candela per square meter in SI units and foot Lambert per square feet in IP units. Luminance again can be measured by light meter, or the only change is now you have to hold the sensors away from the surface, so that you can measure the light reflected from that surface. uh, Generally, you can also, somebody would feel that you can correlate that luminance, that if a surface is appearing brighter, that means it has got higher luminance value. So for example, a white colored wall will appear brighter than a brown color wall. In such cases, one would think that the luminance of the brighter surface might be higher than the other surface. Let's just get into that, because that's not always the case. Brightness is perception of human observer. It's basically a qualitative aspect which we will be covering in the second module, whereas luminance is an objective measurement of a light meter. Hence, it is a quantitative aspect. Just for a simple example, lights will generally appear much brighter at night than during the day in the same space. But we will register. But if you take the light sensor and measures the value, you will have same luminance value from the light fixture. Since we design lighting for people and not for light meters, it is usually important to focus on brightness than luminance. Again, let's just understand now more detail into the qualitative terms. So that brings us to the three qualitative terms, which are brightness, contrast, and glare. Let's start with brightness. As we have already explained, human being judge brightness of an object relative to the brightness of the surrounding. So brightness is cannot be measured. It is basically human perception depending on the surrounding conditions. How bright are the surrounding, what are the surface material, you perceive brightness in that extent. Another example, you have car headlamps which are very bright, very bright at night. You feel you can't even look into that. And if you see the same during the day, you will not even notice that the headlamps are on. So that is a perception of a human being. Let's just look at a simple example. So this is a scenario where let's just try to identify whether this left triangle is bright or this right triangle is bright. So let's take a moment. So I think you must be ready with your answer. Let me just guess. I think you would be thinking that the triangle on the left side is brighter than the triangle on the right side. So now let's just remove the top two black and white triangle and see. So now one can clearly see that the left and the right triangle are of the same color. So it's just because we have created a surrounding around the left triangle which is dark, and a around the right triangle which is light, which is making the left triangle appear brighter than the right triangle. Now moving on to the contrast. By definition, contrast is the difference between the brightness of an object and that of its immediate background. Now, in this image, we see dark colored windows popping out of a light colored wall. So that's its immediate surrounding, and it helps in the contrast. Basically, helps in visual task performance. But let's just change the contrast of this image, and then see how that is impacting our visual. So now, if you see, eventually with excessive contrast will reduce visibility. So this is called glare. We are already not able to see some of the details due to excessive contrast. It is a visual noise that interferes with the visibility. And an extreme bright object against a dark background also causes discomfort and can interfere with our visual perception. This is generally termed as glare. There are two types of glare. One is direct glare, which is caused by a beam of light or a surface sufficiently bright to cause discomfort and loss of visibility. You can look in this photograph. The bright sun is shining right through the street, reducing the direct visibility in the immediate surroundings. Uh, you can have a dark glass to reduce the glare or shield the sun with your hands so that it is not in the field of vision in order to improve visual comfort. Again, another example of glare, which is, there is a bike and there is a sun behind, and you can't see the details of the bike in this image. Though it's a great image, interesting photo composition though. Again, reflection of light sources on glossy surfaces, which cause problems similar to direct glare.